But yeah, we did this. It's a the
I just said I was. Alright, if this is super laggy to start with, I apologize ahead of time. Our internet has gone out of school, so I am trying my best with what we have. I will upload it when I get home, so if you are late seeing this, again, I apologize. So this is a few of the questions I asked from the chapter 1 review. So you asked for 21 through 25. So number 21 asks us to tell, and I'm just going to change this to f of x, whether this is even or odd and why. And so the way I show even or odd or any kind of symmetry is I want to plug in a negative x here, and I get 1 minus the cosine of negative x, okay? And I want you to think about something for just a minute we've talked about several times. If you check on your unit circle here, anywhere you go, let's say cosine of pi over 6 here. I get square root of 3 over 2, right? Well, what happens if I do the cosine of negative pi over 6? In other words, I come here. What do you notice about the cosine value there? I hope you notice that it's exactly the same, right? Let's pick another try. How about pi over 4? Cosine of pi over 4 is 2 over 2. And then if you go negative pi over 4, you see that the cosine there is also square root of 2 over 2, okay? And so we've talked about before that a good property for you to remember is that the cosine of negative x is the same thing as the cos x. It's going to have the same value, even if you negate those theta values, right? So here, this becomes 1 minus cosine x. And this is easy to see that the first equation and the f of negative x are exactly the same. And so when they are exactly the same, then I know that this is even, right, same, even symmetry. This is an even function, right? All right, let's do another one. Let's do number 22. So number 22 starts to get a little bit harder. 22 is f of x. Again, I'm going to do f of x, secant x, tangent x. All right. So for this one, I want to go ahead. I'm going to do negative x. I'm going to change this to 1 over cosine, and I'm going to do negative x. And for the tangent, I'm going to change that to sine. Again, changing all of my x's to negative x. Okay, because remember also tangent theta is sine theta over cosine theta. Okay? All right, so no, from up here, cosine negative x is the same thing as cosine x. So this becomes 1 over cosine x times, here I've got another on the denominator here, another cosine negative x. I'm going to, now the sine of negative x, if you look on, let's do the same thing we did with cosine, right? The sine at, we'll go pi over 6 is 1/2. Now if you go negative pi over 6, so I'm down here, then I get negative 1/2, right? The sine of pi over 4, square root of 2 over 2. The sine of negative pi over 4, negative square root of 2 over 2. And I could keep on those, but just know that the sine of negative x is the same thing as negative sine x because it is an odd function. Okay, so this becomes negative sine x. Now, negative sine x is the same thing. I've got 1 over cosine x times, this is the same thing as negative 1 times fraction, right, times sine x over cosine x. And as multiplication is commutative, I could pull this out front and just have a negative sitting out front, and then I have 1 over cosine x is the same thing as secant x. Sine over cosine, of course, is tangent. And you can see that from what I started with to what I ended with, I have completely opposite signs. So this is indeed an odd function. Okay? Number 23. X to the 4th plus 1 over x to the 3rd minus 2x. So I want to do the negative x I'm just putting in a negative here for every single one. Minus 2 times negative x. Alright, so what I want to do is come through here and simplify. Anything with an even power, of course, is going to be positive. This 1 over. Think about this. If I have negative x cubed, think about this being negative 1 times x, both of them being to the third. I would end up with negative 1x to the third, which is negative x to the third, right? So negative x to the third plus 2x. Okay. Now you might look and go, that's neither because the top hasn't changed. But remember, if you want to negate a function, okay, you negate a function by multiplying the whole thing by negative 1, right? Well, if you multiplied the top and the bottom by negative 1, you've really multiplied positive 1 because a negative divided by a negative is a positive, okay? So you really only need, if you're talking about a fraction, either the top or the bottom to completely negate it. Now here's why. Let me show you. If I were to factor out negative 1 from the bottom here, I'm left with x to the third minus 2x. And of course, I could write this negative 1 times x to the fourth plus 1 x cubed minus 2x. And it is completely negated now because I've multiplied negative 1. And so this is indeed an odd function. Number 24. 24 is 1, help if you can see, 1 minus sine x. So if I do negative x here, I get minus the sine of negative x. Okay. Again, we've already determined that the sine of negative x is equal to negative sine x because of an odd function. So we have 1 minus negative sine x. This becomes 1 plus sine x. And so when I compare to my original function, although the sign in the middle here has changed, in order to be an odd function, I would need both of them to change. There would need to be negative in front of this 1. So this does not show any symmetry. It's neat. And finally, you asked for number 25. And number 25 is x plus cosine x. This is f of x equals. And so I want to again put in negative x. I get negative x plus cosine of negative x. And again, we know that cosine of negative x is equal to cosine x. So I have negative x plus cosine x. And again, every sign has not changed here, only the sign on the x. So this is also neither. Okay. Let me find later. You also asked me to work number 31. So number 31 says to find the domain, the range, graph the function. So I have 2 e to the negative x minus 3. So let's think just a minute about the parent graph here for e to the x. And the parent graph is a growth, right? It's going to have an asymptote here, and we'll just roughly scan it to be this way, right? Well, the first thing I notice is this being a decay, right? So instead of being growth, it's going to come down and be decay, right? All right, still, the domain of the pink is negative infinity to infinity, and my range is from 0 to infinity. But let's do everything else here, that the transformations that are happening in this function, right? I'm sorry, I don't remember where I was with this problem. So the 2 is going to be a vertical stretch here, right? Vertical stretch of 2. And the 3 is going to shift it down 3. All right. So what I'm thinking is 1, 2, 3. should end up looking something like this. And so for part A, we're to find the domain. So the domain of this is still going to remain negative infinity to infinity. Probably. Alright, and my range should be from -3 to infinity. Okay, we're going to graph this just to confirm on our calculator and then sketch what we see. Alright, so I was doing some intersection here with algebra 2. Alright, let's do 2e to the negative x minus 3. Oh, let me get my window back here. I'm going to just do a standard zoom. And there you go. Alright, so definitely azimuth is at -3. If we need a little more exact picture, if I let x be 0, then I would find out that y is 2. E to the 0 is just going to be 1 minus 3. So it would be -1. And then if I could pick another point, this would definitely be a calculator point if you were a calculator problem. If you were asked to find specific points, and the reason for that is because E is an irrational number, right? Everybody knows the value all the way out of E. It would be like asking you to use pi, but then not give you a calculator. So unless you left your answer in exact graphing, we would of course need to kind of estimate that value. So there you go. That's 30. And then you asked about 33. And so 33 is the same thing, but we're doing domain, range, and then sketching a graph. So I have 2 sine 3x plus pi minus 1. So the first thing that what I really want to do is I want to get this in a form where I can do a little analysis on without a calculator. And then I'll get to the part where maybe I do need to use a calculator. So I am going to go ahead and get this in the form that I know I can analyze a little further. Alright, so let's look at what's happening. First of all, let's think about this parent graph that I have, right? I have this parent graph of sine. Sine, I know. 1, -1, pi over 2, pi, 3 pi over 2, pi, negative pi over 2, negative pi, negative pi, negative 2 pi. Okay? And so this parent graph, right, comes this way. Cosine goes through the sine of 0 is 1, right? Losing my mind. The sine of 0 is 0. Sorry, y'all. I don't know if y'all can hear all that yelling going on down the lane. But there's all kinds of things going on around here today. Alright, here's my parent graph. Amplitude is 1. Goes through the origin. Alright. So let's talk about some things that happen here. My amplitude is changing to 2, right? Because it's stretching out. So let's see what happens when I do that. So all of these high and low points are shifting. This is, of course, a vertical stretch. Alright, so we're in the blue now, right? Terrible graph, and I'm sorry. Not only is the amplitude changing, okay, my period is changing. So my period is now 2 pi over 3, right? Which means now, instead of it taking 2 pi, right, in a third of that area, I'm going to make a complete cycle. Now, before we do that, because essentially this problem only asked us for domain and range, right? So before we worry about period and worry about that, we worry about the horizontal shrink, which is really gonna, we're gonna really be in our frequency. Um, let's look at this downward shift of 1, okay? Everything from the blue is coming down 1, right? Down 1 and left pi over 3, okay? Really the only, because my domain is not changing with any of this, right? My domain is negative infinity to infinity. My range is the only thing that's going to be impacted, and it's going to be impacted by this down 1, okay? So the amplitude and the vertical shift are the only thing impacting the sine or cosine, domain, and range. So if I bring everything down 1, okay, what's going to happen now is my top is going to be at 1, right? But my bottom that was at -2 is going to be all the way down to -3. So my range will be -3 to 1. Okay, and it did ask us to graph it, so what I'm going to do, I'm on here, and I am going to do the, what was it, 2 sine. You can do it as you have manipulated it, or your calculator can handle it in the original form. 3x plus pi minus 1. This would be a calculator problem. Okay, zoom 7. I think you could get the domain and range without the calculator. I think past that, the calculator is not a bad thing. I would set my window, instead of going every pi over 2, I might change that to go pi over 3, because I know that it's been shifted pi over 3. I know the period's got a divisible by 3 there. But it's still going out here to 2 pi, and so you could graph what you saw there. And the graph does justify my domain as well as my range here. Let's see, what else did you ask me about? You asked me about number 35, and I'm sorry I didn't go in order. I got this list that I'm 29 on there also, but I'll come back to that. All right, so that was 31 and 33, and now you need 35. So 35 is the same kind of thing. This is find the domain and range. This is in the log of x minus 3 plus 1. Okay, so the natural log graph looks like this. You've got an asymptote here, right? And if you recall, right? It is exponential, the inverse of the exponential. Okay, so here we go. Now let's look at what this is saying. I'm going to move it to the left 3. So as it has moved left 3, 1, 2, 3. And I have moved up 1. So essentially that has not impacted my domain range, right? So my domain is going to be from -3 to infinity. And my range is going to be negative infinity to infinity. And the purple there is perfectly sufficient for a graph on this. You are asked for specific points. And if it's specific points, you will be able to use that calculator, because again, natural log has got a base of e. And so you would be able to come in here because you have that irrational e in there. All right, back to, and I'm almost done. I think I have 1 or 2 more that you asked about. Number 29 and 39. Number 29, so going backwards a little bit here, y equals the square root of 16 minus x squared. And again, I am asked to find the domain and range and sketch a graph, right? Alright, so let's about the graph of square root. Square root of x. 1 looks something like this. So let's look at what each of these things are doing. I have got a negated x here, and a negated x, we all know, is going to reflect that. I'm trying to do this before now. Okay. So as we look at this, we might be thinking, okay, this is going to negatively reflect here, and it does have to do with reflections, but if you think back, and a lot of you said you had not seen it, this is the equation for that semicircle that we saw. And remember, I told you this is kind of derived from the equation of a circle. But anyway, if you look, this is going to be a semicircle with a radius of 16. So essentially, really what it's going to do, 1, 2, 3, 4. 1, 2, 3, 4. It's going to look like this. Okay, so it's this piece shifted and all, but you also get the negative side of it here. So here we got the domain on this one, and again, you could graph this on your calculator. If I did the square root of 16 minus x squared times 6, you would see that semicircle. Okay. Domain here is going to be negative 4 to 4, and the range is 0 up to 4. Alright, that was 29, and then now let's do, I think there was one more, 39. My internet light is still sitting here blinking, so we'll have to do this whenever I get home. This is to write a piecewise function for the following, and you do have a couple slides in your test tomorrow. 1 and 1 and 2. And so it looks like there is an open, a closed, and an open, and these connect, and then it looks like there is a closed, and an open, closed, and a connect, okay? So essentially this is two lines, so let's look at what the equation of these lines are. This has a y-intercept of 1. It has a slope of -1, so this is y equals negative x minus 1. But I'm going to restrict that main force in just a second. This one, if it kept going, right, would have a y-intercept of, and I'm sorry, this is plus 1 because it's crossing, would have a y-intercept of positive 2, and it has the same slope. These are parallel, so this would be negative x plus 2. It has just been shifted over to the right one. Right, so my equation would be negative x plus 1 when, and here I'm between, on my x's, I'm between 0 and 1, right? It includes 0. It does not include 1, right? And then for this line, negative x plus 2, this time from 1 to 2, 1 to 2, inclusive on both of those. And I think that wraps up y'all's question.